Hi everyone. Are the triangles similar? If so, state the similarity and the postulate theorem that justifies your answer. So we have 6 problems here and we can get started. So for number 10, the angles all must be congruent. So what I'm going to do is see if on number 10, I'm going to take 180 degrees minus 92 degrees minus 57 degrees and see what I get. So 180 minus 92 minus 57 gives me 31 degrees. So that means it's not going to work because if these were similar, this would have to be 31 because this one is 31. All right? The angles are not congruent. So let's look at the next one. We have all sides are congruent for the first one, and all sides are congruent on the second one. So it doesn't really matter what the measure is that we know all the angles are 60 degrees because this angle across from the sides are also the same if the sides are congruent. So for 11, yes, it is similar, and the way we're going to write it is by the side, similarity. And I can't spell similarity theorem. So these two triangles are similar. Now the next one is 12. So I'm going to rewrite this one and make it look like my bigger triangle. So the right angle goes here, and that's V. And 3 goes with AV. So I'll put the A here, and that's a 3. And this would be Q, and this is 4. So let's look and see if they have the same scale factor. Basically, they do. So, well, this is actually, this goes, this should be 3 to 4 like this. This should be 3 to 4. Sorry about that. So basically, you can take the triangles and know that 6 divided by 3 equals 2, which also equals 8 divided by 4. And I'm taking these two together and these two together. And also, this is your Pythagorean triple. 3, 4, 5 is the Pythagorean triple. So you know this is 5. So therefore, this length here would be 10. So these two triangles are similar, and it's by side, angle, side, similarity theorem. And that's because of the right angle here. So we didn't have to do the triples here. We could have just used the side, angle, side. And for 13, I have this one. So we have a right angle here and a right angle here. These two sides are congruent. So this one is a yes, and it's by the side, wait, it's for 13. It's by the side, angle, side. Sorry about that. Side, angle, side, similarity theorem. Because you have an angle here. This angle here. So, since these are both right angles, then that means the sides, we have the two sides here. And the next one is this one. So let's look at 14. If I flip this one around, so I'm going to rewrite this one, make it look more like that. So this would be X and Y and Z, and these two sides are congruent, and this is 6 and this is 9. And because of the angles, we know the sides, and we have a 4 here from Y to Z. So everything is filled out because these are congruent. So we have 3 sides. So that's called side, 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 similarity theorem. And for the last one, 15, let's look what we have. The same thing. Let's. I'm just going to write them a little bigger. I made this picture too small. So you have 30 here. These two sides are congruent, and then we have 6. And the same thing for this one. We have this is 30, and these two sides are congruent. And if the two sides are congruent, so are these angles. So these angles are also congruent. And this was 6. This is 4. So this one is by your side, angle, side. So do you see it's side, angle, side, side, angle, side. Similarity theorem. And that's it. Thank you. Have a nice day. Bye-bye.